Hey guys, welcome to my channel Design with Ruzbe. Continuing with CSWA practice problems, today we'll work on question 2.5. Let's take a look at this question. So in this question, unit of measurement is millimeter gram second. Like always, when we start working in SolidWorks environment, we need to make sure that we are having the same unit of measurement. Now, looking at this geometry, definitely this is not a symmetric geometry. You can see different features in different location, and you can see different view in this question. You can see the top view here, you can see the front view shown here, right view, and we also have detail B, which is showing some dimensions regarding the top surface. So the way I want to approach this question is that first I want to focus on the base of the geometry. You can see that we have this rectangle here, which is the base of the geometry. So I want to make that first, and then I'm going to make this second piece, the large piece that you see here, and then I'm going to focus on the top piece, and at the end I'm going to work on this triangle, and then we're done. Okay, so with this introduction, let's jump into SolidWorks and start modeling this part. So in SolidWorks, first thing first, we need to check unit of measurement, and we have the correct unit of measurement, which is millimeter gram second. So we are good to go. Now I'm going to start from the top plane. So I click on the sketch tab, choose the sketch command, and then I'm going to choose top plane. Now here I need a rectangle. So what I can do from a sketch tab, I'm going to click on rectangle command, and then here is my rectangle. Now we need two holes in this rectangle, so I can click on circle command, and then here I have first one and second one. So now looking at the geometry, we know that the center point of these holes must be in a same horizontal line. So what I can do, I can click on center point, hold control, and then click on this point, and then I'm going to click on horizontal relationship. Now, looking at the front view of the geometry, we can see that the length of this geometry should be 78 millimeters. So I can click on a smart dimension, and then I click on this line, and this should be 78. Looking at the right view of the geometry, we can see that the width of this rectangle should be 41 millimeters. So I click on this line, and this should be 41 millimeters. Also, looking at the top view, you can see that the diameter of the hole is 10 millimeter, and you can see the term typical, which means that 10 millimeter is applied to both holes. So what I can do, I can click on this hole, dimension should be 10, dimension should be 10 millimeter. Now, as for the distance between the lines that we have and the center point of these holes, if you look at the top view, you can see that the distance between the center point of the hole and the bottom line should be 12 millimeters. So I set this one as 12 millimeter. Also, the distance between the center point of this hole and the side line, the vertical line, should be 20 millimeters. So I set it as 20 millimeter. Now, as you can see, the left circle is fully defined. It's shown with a black color. The only circle that we have here, or the only component that we have which is not fully defined, is the right circle. You can see that this geometry is shown with blue color, which means that it's not fully defined. So let's take a look at the question and see if we can define the location of this hole. So in the question, you can see that from the top view, we don't have any specification for the location of the right hole. Looking at detail B, nothing is related to the right hole. Same for the right view, you can't find any sort of information, and also in a front view we don't see any information. So again, I know you most probably you're tired of this, but we don't have enough information in this question. So what can we do to solve this issue? The interesting part is that the location of this hole is not going to change the final answer in this specific question. You may ask why I'm claiming this. And the reason is that at the end of the day, we want to find total volume of the object. So when we are dealing with this hole, the volume of the hole is a function of the diameter of the hole and depth of the hole. So as long as we know these two dimensions, it doesn't matter where we put this hole, the volume that is taking is always the same. So at the end of the day, we are going to find the total volume and the correct answer. So let's go back to SolidWorks, define a location, arbitrary location for this hole, and at the end I'm going to show you that if I move this hole, it's not going to change the final answer. So for now, as I explained, I'm going to define an arbitrary location for this hole, and the easiest solution here is to have this assumption that the location of the hole is kind of same. I can click here and then click here, and this dimension should be 20 millimeter. And now you can see we have fully defined geometry. Okay, awesome. Click on OK, click on feature, click on extruded bus, and now we need to extrude this feature. We know that the thickness that we want is 7 millimeter. So I'm going to change this one to 7, and then I click on OK, and now I have my first feature. Okay, great. Now for the second feature, I'm going to make that feature on the back surface. So what you can do here, you can click on a sketch, click on a sketch command, rotate the part, and then click on this surface. And now here, I'm going to make a 2D sketch. So to do this, from the sketch, I'm going to click on line command. And here I start drawing from this corner. It goes up, and then we go to the left, and then to this point. Okay, first of all, same as this right line, the left line must be also vertical. So I click on this line, and then from the constraint, I'm going to choose vertical. Okay. Now we have two dimensions. We know that the height of this line is 33 millimeters. So I click on smart dimension, and I'm going to size this line. So it should be 33. Also, we know that the angle between the blue line and the bottom line should be 25 degrees. So I click on the line, I click on this bottom line, and then here it should be 25 degrees. Okay. Okay, so that's the sketch that we want, except that it's not fully closed. So what I need to do, I click on the line command, and then I'm gonna click on the left point and connect it to the right point. Now I have fully closed 2D sketch. We are ready to extrude this piece. I click on feature, click on extruded bus, and then here I'm gonna extrude this component. The direction, of course, is not correct. So what I can do, from this direction tab, I can click on reverse direction. Click on it, and now you have 7 millimeter thickness for this second feature. Click on OK, and that's it. Great. So now we have our second feature. Now let's focus on a third feature. As you can see in the question, the third feature is placed on this surface, on this inclined surface. So what you can do, you don't need to define a new plane. You can simply click on a sketch, click on a sketch, and then here SolidWorks asks you to define a plane. You can click on this surface, and now this surface is activated. So it's time to make a 2D sketch. To do this, from a sketch, I'm going to click on rectangle command, and then here I'm going to have this geometry. We also need some sort of cutout inside it, so I can make that one as well. From a sketch, click on circle command. Make one circle here. Let me try it again. One circle here, one circle here, and then we also need to connect these circles. So that's one, and that's a second one. Okay, so now let's add one more relationship. We know that the center point of these two circles must be in line. So what I can do, I can click on the center point of the large circle, hold Control, click on center point of this small circle, and I choose horizontal relationship. Now, looking at the geometry in a question, we know that the diameter of the large circle should be 18 millimeters. So I click on the smart dimension. This circle should be 18 millimeters. Also, the distance between these two lines, which is equal to the diameter of the circle, should be 8 millimeters. So I can click on these two lines. The distance should be 8 millimeters. Now, let's add other dimensions. The distance between the center point of these two circles must be 30 millimeters. So I can click on this circle. I can click on the center point of this circle, and this distance must be 30 millimeter. Also, the distance between the center point of the large circle and the right line should be 20 millimeters. So I can set this one as 20. Now, we also know that the distance between this line, the left line, and the edge of the geometry should be 10 millimeter. And they're showing that as typical 10 millimeter. That means 10 millimeter is applied to the other side as well. So I can click on this line, and then I can click on this edge, and this distance must be 10 millimeter. Now, if you look at the right view in a question, we can see that the width of this rectangle should be 45 millimeters. So I can click on this top surface, I can click on this line, and this distance must be 45 millimeter. And finally, the distance between the center point of the circle and the top edge should be 20 millimeters. So I can set this one to 20. Okay, great. Now you can see that we have a fully defined geometry. Let's remove some unnecessary lines. So to do this, from a sketch, I click on Trim Entities, and then I'm going to remove this line, I'm going to remove this line, and now we have our geometry. Next step is to use Extruded Bus feature. So click on OK, click on Feature, click on Extruded Bus, and now we can extrude this feature. The only issue is the direction of the extrusion, so we can simply click on Reverse Direction. Thickness would be 7 millimeter, again because in a question they mentioned that it's typical 7 millimeter. That means that it's 7 millimeter everywhere. So click on OK, and now I have the third piece created here. Okay, awesome. Last step is to make the triangle in this part of the geometry. So let's do that. Click on the sketch, click on the sketch, rotate the part, and then select this surface. Now all we need to do is just to make a rectangle with 3 lines. So click on Line command, and then I start from here, go here, going down, and going back to the starting point. We know that the height of this rectangle should be 25 millimeters. So I click on a Smart Dimension, I click on this line, and the height should be 25 millimeters. Now we have fully defined geometry. Click on Feature, click on Extruded Bus, and then again, change the direction, click on OK, and now we have our last feature made in this geometry. Okay, awesome. So this is the final geometry that we are looking for. Now it's time to check the total volume and make sure that this is a correct geometry. So let's go back to the question and check the total volume. The total volume mentioned in the question is 62,810 cubic millimeters. Let's go back to the question and check the total volume. To check the total volume, we can click on Evaluate, and then we can click on Mass Properties. And here you can see that the total volume we found is 62,809 cubic millimeters. If you round up this number, you get exactly the same answer as it's mentioned in a question. So this is showing that our modeling is correct and there's no issue with that. Now let's go back to the first assumption that I had. If you remember, I told you if I move the hole, it's not going to change the total volume. So it's not really important where I put that hole. So let's do that. What I can do, go to the base geometry like this one, click on the arrow, click on this sketch because I want to modify this sketch. I click on Edit a Sketch. And here, simply instead of 20 millimeter, let's assume this one is 30 millimeter. You can see that the hole was moved. Now click on OK, click on the arrow on the right side, and the geometry is now updated. Let's check the total volume. I click on Mass Properties, and I can see that the total volume is still the same. No change to the total volume. So although we didn't have enough information in the question, it didn't have impact on a total volume and a final answer. So we were able to model this part, and the answer that we found is correct. We're good. Okay, so that's it for today. I hope you guys enjoyed this video. If you have any comment or feedback, please leave comments down below. Thanks again for watching. My name is Ruzbe. Hope to see you again soon in the next videos.